Hello, I'm Derek and welcome to this video about writing PHP extensions. In the previous video, we have created our method to retrieve our points array back out of our line string with a getCoordinates function. However, we haven't actually implemented any validation yet of what data the line string constructor is going to accept. That's what we're going to do in this video. Let's start off where we ended last time. In our line string C file, we have our constructor defined. We accept our points array and then store it as our property. In between, we'll have to do our validation. I like splitting this out into separate functions, especially because we might be able to reuse this function at a later time. If the validation fails, we'll make the function throw an exception. We need to guard for that with return throws here, which means that if it's not valid, PHP will check for whether an exception has been thrown. If so, it will then return from the function. If not, then it will show you a warning message that an exception wasn't thrown, as a help to make sure that we implement things correctly. The checkValidLineString function, of course, needs to accept some arguments. Most importantly, the points array itself. Because we want to do some proper validation here with some better error messages that can help our users, we also have to specify which argument number it is. For some other methods that we're going to have, the line string won't be in the first argument like we have here. Because it's always the first one in the constructor, we just specify the number 1 here. Now we can write our validation function itself. It is going to be a static function because we're only going to use it in this C file for now. We're going to return true or false depending on whether the line string is valid. Hence a boolean. The name of the function we already have, which is validLineString. It accepts an argument number and our points array. In this method, we're going to do a bunch of checks. If any of them fail, we're going to throw an exception and return from the function with false. If everything is correct, we'll simply return true. So that's what we'll start with. Now we need to decide on when the line string is actually not valid. A line string needs to have at least 2 elements, a starting and an ending coordinate pair. So that's going to be our first check, because it's also the cheapest. Right now we're adding the checks with comments, but of course we'll have to fill this in with actual code later. For each of the coordinate pairs in the array, we need to make sure a few things as well. Again, this is still pseudocode, we'll fill in the rest later. For each of the elements in our line string array, we need to make sure that each element is also an array. We also need to make sure that each pair is exactly 2 elements long, so we'll check for that. PHP arrays can be both associative or index. We only want to have indexed array elements, so we need to make sure that each pair is indexed by the numbers 0 and 1. We'll have to do that separately for checking whether it's a 2-element coordinate pair. We also need to make sure that each element is either an integer number or a double number, and that the range fits in the range suitable for that index element. Although we can check for an element just having an index 0 and 1, we also need to make sure that each of these types are either an integer or long, the 2 data types that PHP supports for numbers. We'll do that in the same check, otherwise there will be just too many. For each of the elements, we also want to do a range check. The range check is going to end up differently whether it's a long or double, because the way how to access the data depends on the type. For that, we'll end up having to do 2 checks. If it's a double, we have to do the same thing. The second element, element 1, is a latitude. Latitudes are only between -90 and +90, so we'll have to check for that as well. These are all the checks that we need to do. Now let's start implementing them one by one. We already know that the points array holds an array because we have checked that in a constructor already. So we now only have to check for the number of pairs. We do that with a function called send#num_elements. It accepts a hash table, let's call it ht for now, and then we need to do the comparison with the amount. Send#num_elements operates on a hash table, which we can obtain from the z file with the hash of macro. If the element is not 2 or more elements, we'll throw an exception. We'll use the send argument value error function for this. It would create an error message in the same format that normal PHP would do for validation of arguments. For this one, we'll have to specify the argument number therefore. And then we can use our error message. After we throw the error, we'll then have to return false. Let's see if this compiles and whether we can create some tests for this as well. Our previous test still works, so that's good. But we'll want to create a new one for this. For validations that we know that will throw an error, I prefer creating a separate test file, so that we can check all the negative code paths in one go. I prefer using the postfix errors in test file names for this. Let's set up the tests as we usually do. We're going to test a whole bunch of different scenarios. Therefore, I will create a set of data points that we can loop over so that we don't have to do the constructor of the line string every single time. This is very similar to a data provider in PHP unit tests. I'll define an array tests, and each element in this test array is going to be a line string with errors in it. We'll loop over them first. We'll use try so that we can capture the exception. We'll have to catch our errors, which should all be of the type value error. And if it finds it, we'll show the class of the error as well as the error message. If we run this test, of course it should pass because we haven't added any tests. Let's try that first. And indeed, it succeeds. However, we've just added a validation check, so we should create a test case for that. This is in the case a test doesn't have two elements. That means it's either 0 or 1 pair. Each of these should throw an error message. Let me run the test again. I can run make test straight from Vim, which is kind of handy here. I'll do that by using : make test. And you can see an error. I will open our error messages in the separate file with our output. And indeed, our error message is as we expected. I'll copy and paste those. I will now run the test again. And now it succeeds. And Vim warns that the out file no longer exists. The next thing to check is whether each element in the array is actually an array. For that, we need to loop over all the array elements, which we can do with the macro send-hash for each val that we've also used before. It accepts the array, or rather the hash table, and the element that we're going to want to check. At the end, we also need to do the equivalent macro. We also have to define element, which is a z-val that's going to get returned for each of the iteration in for each. This should now compile. And it does without errors. The first thing to check is whether each element is an array. For that, we use the ztype_p macro. If it's not an array, we need to throw our error message. And return false. I'm of the opinion that all error messages and exceptions need to be very useful, telling the user exactly what is going on. By just saying that a single element is not actually an array, we're not helping the user finding out which of the elements in the array it is. What we'd really like to see is that it also tells you which index in the array is wrong. So for that, we're going to keep track of which elements in the array this is by a simple counter. I'll define that one as element number, which will initialize at 0. That also means that at the end of the loop we have to increase this value as well to keep track of what's going on. By having this element number, we can then modify our message to show what's going on. As this is a size t argument, we'll have to use a specific format specifier here in C, which is called zd. And then we need to add that as argument as well. Let's see if we can make this compile. I made a typo somewhere. I made two typos actually. I use element number here, element num1s, and at the bottom element underscore nr. I'll fix those. Now it works. Let's now add a test case for this situation as well. in order to not trigger the not enough elements error, we'll need to make sure that we create an element with some pairs in here. For the first test, I'm creating a normal one. I'm creating two elements where the first one is not an array element, but the second one is. This now should throw an error, as you'd expect. Let's try this out by running make tests. This test still passes. Which makes sense, because we check for whether it's an array, not for how many elements are in there. What the test really should do is having a number here instead of an array. Let me now run this again. And now we get our error message. I will open up the output as well. And here you see it. The points array element 0 is not an array. And we'll update our test file. Similarly, we can also check that for other elements. I'll add one more just to be on the safe side for a third element, which of course its index is number 2. If I run the test, this should also work without errors now. There you go, this works fine now. We'll continue with the other validations. The first one is to make sure that we have two elements. We have done a similar test before, so I'll skip over this fairly quickly. We'll now also create a test for this. We'll run the test and then add the output like we've done before. And indeed, their error message is correct. It tells us that the second element is not an argument pair. And now the test works again. We'll do the other test in quick succession, because otherwise this gets a little bit repetitive. The next check to do is whether we have an element with index 0. Instead of just checking, we're going to just obtain it, because we're going to have to make use of this element later anyway. The function z#indexFind tries to obtain the 0th element here, which is rather the first element. We have to do the same thing for the latitude as well. But that is of course element 1. Each of these are z files, so we have to define a variable for them as well. We haven't done the checker yet, we only just tried to obtain it. So we'll now add the check for this. If it doesn't exist, this is an error. It is also an error if this element is not a long or a double. So we'll check for that in one go as well. I will use the same error message here as we used for if there were not two elements in the array. We'll have to make the same check for latitude as well. Let's see if this compiles. It does. For each of the elephants, we also need to do a range check. As I said before, we'll have to separate these into long and double checks separately. Let's do the one for long first. We will create a different error message for this. It's all becoming a bit large, but that's okay. As you can see, I'm including the actual number in my error message. Again, this is to help the user that makes use of the function. The next check to do is the same but then for double. The reason why we need to do two different ones is because lval needs to be changed to dval here. And similarly, the printf specifier can't be ld but needs to be f. And now we can also copy these checks for the latitude. We'll need to make sure to replace longitude by latitude and 180 by 90. Now this should compile. That's fine, let's see if the test still works. They should, because we haven't added any cases for this yet. So no errors there either, but we will have to create cases for this. There's a fair bunch that we'll need to check for. The first one is to make sure that each element is either going to be a number or an integer. Here we make sure that the latitude is right. And in this one, the longitude. For good measure, I will also use something else than a string. Some of those I'll keep as integer too. The last is the out of range tests. All these 8 tests should fill now when we run the tests. The last 8 tests that we have created are these. These all look fine, so we'll copy them over and modify them to make sure that we don't use the object ID in them. I don't think I've covered all the test cases, such as integers for latitude ranges or floating point numbers for longitude ranges, but I'll leave that as an exercise. We'll run the test again. There is still an error. Let's see what it is. Besides the .out, there's also a .diff, which should show the differences. It is on line 7, and I think I just simply used %1 instead of %d. So let me fix that. And now the test passes. With this, we've now finished our validation function. In the next video, we're going to add our simplification function again. Thank you for watching, and I'll see you next time.